When we see this sign, we have to look both ways before we can go on. You might not think that a simple shape like this triangle is a powerful tool of mathematics, but it is. The triangle affects many measurements and construction techniques. It's sturdy, and unlike me, it doesn't yield. I wouldn't want to treat just any bike that tough, but my cycle's made to take it. Look at the triangular support. The people that put this bike together used this shape on purpose. Why? Well, the triangle is the simplest shape made of line segments. It has only 3 sides, but it is very rigid. In fact, it's the simplest but most rigid polygon. Look, it's not collapsible. That's why we rely on its strength in lots of things. The triangle is a sturdy construction. Just about everything has a specific name. Like this bike is a mountain bike. Well, triangles are no different. We can look at their sides to give them names. Scalene triangles have no sides the same length. Isosceles triangles have 2 sides the same length. Equilateral triangles, on the other hand, are triangles with all 3 sides the same length. There are other names we sometimes use when talking about triangles. 2 triangles that have the exact same size and shape are called congruent triangles. One can fit exactly over the other. If the triangles are shaped the same, but not necessarily the same size, we call them similar triangles. Of course, all triangles, whatever you call them, have at least 2 things in common. They all have 3 sides, and they all have 3 angles that total 180 degrees. I'm glad I'm not superstitious about being underneath ladders. I'm inside a special kind of triangle. It's called a right triangle because of this 90-degree angle. By the way, it could be isosceles or scalene, but never an equilateral triangle. Right triangles give us all sorts of special tricks while measuring. Let me show you. First, you see the 2 legs? No, not my legs. The 2 sides forming the right angle are called the legs. The side opposite the right angle, that's the longest one, it's called the hypotenuse. You need to know about these words so I can tell you about a special formula, the Pythagorean theorem. Here's a way to remember it. It sounds like I picked it up at a special store for triangle formulas called Pythag R Us. Pythagoras was one of the people who studied right triangles a long time ago. This theorem says that in a right triangle, one leg squared plus the other leg squared is the same as the hypotenuse squared. Let me show you geometric shapes instead of algebraic equations. Leg squared plus leg squared equals hypotenuse squared. Or, check it out. On the wall, 4 squared equals 16. On the ground, 3 squared equals 9. And 16 and 9 together equal the ladder, 5 squared, or 25. What good is the Pythagorean theorem? Well, if I know 2 sides, I can figure out the length of the 3rd side. Using a property of right triangles as our tool, this theorem gives us a way to find a length. Have you ever thought that shadows and triangles could help mathematicians and scientists in their jobs? Let's imagine a right triangle, where my body is one leg of the triangle, and the shadow I cast on the ground is the other leg. The hypotenuse is a line from the top of my head to the end of my shadow. Now imagine an even bigger triangle, formed by Baby Kong, his shadow, and a line connecting the ends. His triangle and my triangle are similar. Remember, same shape, different size. So if I figure that Baby Kong's shadow is twice as long as my shadow, I know he's twice as tall as I am. Oh, by the way, this also works for figuring out Mama Kong's height. Shadow 3 times longer, height 3 times taller. We could use the shadow principle to measure the height of this building, because I'm sure I couldn't find a tape measure long enough to do it. But even using shadows in this case might not be too practical. Instead, I'm going to use something different to measure the height of a building. Tangent. A tangent is a comparison of the 2 legs of a right triangle. More specifically, tangent is the ratio of the side opposite the angle to the side adjacent to or next to the angle. For each angle, the tangent equals a certain value. For instance, a 25-degree angle has a tangent ratio of about 466 thousandths. A larger angle, like a 50-degree angle, has a value of about 1 and 192 thousandths. And to make your life easier, constant values like these are placed in most calculators and charts. In our example, we'll use the tangent formula to determine the height of the building. Substitute 70 degrees for the measured angle, and replace the distance along the ground with 45 feet. The approximate tangent value of 70 degrees is multiplied times 45 feet to obtain the height of the building. The same concept can be used to measure even harder to get distances, like across water. Sailors can use the angle from their eye level to the top of another ship's mast and the height of another ship's mast to find the distance to that ship. The angle is measured with a statometer, and sailors carry with them a reference table which lists the standard heights of most ships' masts. Have you ever wondered why surveyors stand in the middle of the road with their equipment? Well, they use triangles to measure where future bridges and roads will be built. They use a sight to measure an angle, and they can use an infrared beam instead of a tape measure to measure their long distances. They know the wavelength of the infrared beam and the time it takes for the beam to get to their reflecting prism and back. These numbers are then plugged into a formula to find the other measurements they need. Their equipment is completely computerized, and it's called a total station. It's a lot different from the surveying tools of long ago, which evolved from a simple compass and a combination of a compass and a telescope called a transit. Today, with modern tools, astronomers can measure the distance to the moon within centimeters. Some 2,000 years ago, people used angles and shadows and their knowledge of triangles to measure the distance to the moon. And they actually got within about 16,000 kilometers. Not bad considering it's about 384,000 kilometers to the moon. One way to measure the distance to the moon involves a phenomenon called parallax. To use this method, you view the moon from one position on Earth and then from a different position. The moon appears to shift its position in the sky, but it's really the angles of the 2 lines of sights from the 2 positions that are different. These angles and the distance between the 2 positions are enough to compute the distance to the moon. You can experiment with parallax yourself. Hold your thumb in front of you and look at its position against a distant object. Close one eye and look at your thumb. Open that eye and close the other eye. Let me show you what that looks like. Your thumb appears to move, but it's your viewing position, left eye or right eye, that is changing. We've seen that whether by land, sea, or air, triangles are trusty tools to measure distance. Well, they're handy for measuring area, too. We know that for any type of triangle, right triangle or not, area is measured the same way. It's half the area of a rectangle. 1/2 base times height. Which one of these has the most area? Well, these aren't quite triangular. And I don't like the crusts anyway. It's not so easy to tell just by looking which piece has the greater area. Here's where the formula comes in handy. First, I pick a base for the triangle. I'll make it this side. That means that this is the height. Now I just work out the formula, and I have the area. Hey, these two triangles have the same area. We can find the area of any irregular polygon, as long as we can chop it up into triangles. Here's another thing I like about triangles. If you put a lot of similar triangles together like these, you can make some pretty awesome fractal designs. So remember, next time you're out on the road, triangles are those simple shapes that are tough. And knowing a few math tricks help us measure hard-to-get places. With triangles, you can know a little and learn a lot.